This was our problem from last time. We already had our conclusions. Wilcoxon Rank Sum, our p-value was 0.005437, less than 0.05. We did reject the law. We concluded that the median survival times for treatment A is greater than the median survival time for treatment B. And prior to that, we did the t-test. The conclusion was similar, even though the conclusions are similar for both Wilcoxon Rank Sum and t-test. There's the concept of ethics and appropriateness. You have to do the right procedure. This is the correct procedure. Why? It's right here. Violation of assumptions, the data is not normally distributed. Okay. That was my function command that I used last night to do a Wilcox test. As you can see, I use treatment A to be X and treatment B to be Y. So it goes in order. My alternative is to test that the treatment A median survival time is greater than treatment B median survival time. That was the summary. Okay. Do we see U in the output?
No.
No.
Yes, we do see it.
Wow.
It's right there as W.
Very good. So, even though you have it listed as W, it is U. It is not giving us W. So if we want to find the true W, we must add the term n1 times n1 plus 1 divided by 2. Agreed?
That's why you wanted that right there.
Very good, Phoebe. That's why I wanted that term 1770. So 1770, how did I get that? I got that number by doing n1 times n1 plus 1 divided by 2. I am going to add U to it. U is 2,459.5. I get 4,229.5. Yes? Under the norm, prior to doing this in R, we had the expectation of probably 3,599. I added 2 standard deviations, subtracted 2 standard deviations. Again, under the norm, null being the median survival time for treatment A is less than or equal to would be the reference. Based on the interval under the null, which is, I guess I'll just type right here as always. Keyword being normality assumption. This is a quick way to determine whether we are going to reject the null or not. So under normality assumption, we calculated the expectation to be or we use the expectation of 3,599. we had the formula for that. We used a standard deviation, sigma, for the test statistic, W, and that was 192.8. And we sort of came up with an interval. So under null, what is our null if we go back up? Null is median survival time of treatment A is less than or equal to median survival time of treatment B. So under the null, I shouldn't say like an approximate interval for W is add two standard deviations, subtract two standard deviations. I get a value of 3,213.4 all the way up to 3,984.6. What does this mean? If there is evidence to support the null, and if I repeated the study over and over and over again, the value of W will fall between those two numbers, 3,213.4 and 3,984.6. 95% of the time. That number is coming from experience. Oh, statistics 2023, empirical rule. So, under the null, I expect W to fall between those two values. RW, does it fall between those two values? Wilcox test, even though it is listed as W, it is not W, rather, it is U. 2,459.5. We took that value and we added that shift N1 times N1 plus 1 divided by 2. 1770. So based on the data, I'm getting a test statistic W as 4,229.5. Therefore, W equals U plus that number, 4,229.5. 0.2.
Oh wait, no T. You broke T.
Oh, I see. Okay. You know, it happens. Okay. Look at that number, W. The interval under the null hypothesis is right here. Does W, which you got from the data, does it fall on that interval? Yes or no? Easy question.
No.
No. So under the null, make this attention. Under the null, I should expect values for W between those two endpoints, I am getting an answer of 4,229.5 based on the sample again. So does the sample have evidence towards the norm?
No.
Very good. So since it doesn't fall in the interval right there, which is under the norm, whatever the sample is giving us as W is way out, indicating that there is no sufficient evidence to support the norm, rather there is evidence to support the insanity. Does that make sense?
Yes.
Now, we don't draw a distribution, you know, a bell curve, rejection region, all that stuff here, because the null distribution is a Wilcoxon Rank Sum distribution, and it is simulated. It typically doesn't have a shape. Dealing with ordered statistics, very painful, computationally heavy. But these tests are quite reliable in terms of power. Are we clear? Does that make sense? Does it make sense as to why we rejected the null?
Yeah.
A word of caution, the things that I wrote here, line 60 through 63, I'm making an assumption, you know, a normal approximation. You might say what Richard wants to say, but in 45.02, non-parametric inference, we got into the theory of approximations of non-parametric tests. Hello. Good. Okay, let's do one more example on this, and then we can move on to sign rank next time. So I am going to go back to my BSDA package.
Ooh, we get to pick a new sample.
Exactly, you get to pick a new one.
This is fun.
It is fun.
Yay! Okay.
At least one person is excited. I mean, two, including myself.
There you go.
Okay.
Stay still just fine.
Huh?
It was gonna stay still just fine.
Okay, yeah, that's me. True. Okay, so we've looked through A, B, C, D. I mean C. Let's try D. You have to pick up or pick a sample that is applicable for Wilcoxon Rank Sum. Let's do Wilcoxon Rank Sum, but which case here do you think is reasonable? Darwin, Dealers, defective.
Why is there no E at the defective?
I don't know.
They spelled it wrong.
Some people are lazy.
Yes.
So let's see. Okay, I can see as of now there are two data sets that qualify for a Wilcoxon Rank Sum.
Oh, I think.
Alex,
With develop.
the developed one. Why? Why so?
This is the demographics, this is a 2-year college, 4-year college.
Very good. So here we are comparing demographics, 2-year colleges, 4-year colleges. So two different samples. Are the samples independent of the populations independent? Yes. 2-year colleges is completely different from 4-year colleges. So that is a good candidate. So now that Alex picked one for us, I want you to pick another one. There is another one in that list that you see.
I'm thinking.
Degree.
Yeah.
Come again.
Degree.
Ah, very good. That will qualify. So percent of bachelor's degrees awarded for women in 1970 versus 1990, independent populations, and certainly works. So I've got to change again.
Wait, what was
There's
that?
another one.
Darwin,
Why, Phoebe?
because there's two samples, a cross-fertilized and a self-fertilized.
Very good. So there are two different groups, cross-fertilized, self-fertilized, very similar to treatment A, treatment B. Right? If you want to make a one-to-one connection between our previous example and this one, Darwin, cross-fertilized, treatment A, treatment B. 1970 here for the degree data set, treatment A, 1990, treatment B. And lastly, 2-year colleges, development data set, treatment A would be 2-year colleges, treatment B, 4-year colleges. Good? Okay.
Can we do develop
Remember.
education
So,
major?
Now we can pick one. Phoebe says develop.
Should we support Phoebe?
Yeah.
Yeah, thanks guys.
Okay.
Much appreciated.
We will see if the data is in our favor. That's important, right? Um,
I will release this character canvas today, and I am going to post an announcement. What are you supposed to do?
Read it.
Read it, thank you. Do you think that's a workable answer in our case? For our example, Sydney? No, because we don't have a quantitative measurement. So Phoebe.
Okay, we tried.
we tried, right? Let me double check.
Um,
Perhaps some Cullen's. I doubt it.
No, there are only two variables, college and race, both of them are qualitative.
All work. All right, moving on. Next,
Okay, yeah.
right? Let's try degree.
I got into the wrong one.
No case.
They're so annoying.
Wow.
I hated bio too. What's the world?
Ah. Starting. Let's see. Hopefully, this one's got some quantitative numbers. Is that going to work?
No, oh no, we're gonna have to do this.
Again, I make this statement, a statistician, a good bit of time spent, or for the most part, will be spending time in restructuring and analyzing the data and,
Make sure if we can use an appropriate procedure. So that one is not going to work. I guess it's going to be Darwin.
Oh god, here we
We
go
will see.
again with this guy.
Aha.
Would you look at that?
Would you look at that? So, self-fertilized, cross-fertilized. Later on, I'll do a nested design, similar to our wafer problem from a long time ago. There is another variable here, which is the fourth. We have to account for it, but for the sake of this problem, I'm not going to. So,
No, we are.
You can't just ignore the data.
Yeah.
Come again?
You just can't ignore it.
You just lectured
True.
about ethics and now we're ignoring data. Like,
well, I'm glad you are paying attention. for the sake of this class, just to demonstrate the example. Okay, I'll put, an advisory.
Please do not trust what we're doing.
For educational purposes only. Okay, happy now?
Oh, God.
Okay.
You're killing me,
Uh,
baby.
Darwin from BSDA package. So one is cross-fertilized. Other self. Nice thing about R is going to give us the option to do left tail, right tail, two tail. Again, on an exam, your job is to interpret the data. That's all. Or interpret summaries.
So we do a two-tail test?
Look on. So
I don't know. Why would you do that? It's just the data. Yeah.
So what did he study on the height of the plant in inches? I'll say it was fertilized. So maybe one to do that, it wasn't the same between cross-fertilized and self-fertilized. I'm blind.
No, it's height of plant.
So
Facts.
M_C, is it the mean or the median? Median. Median height of cross-fertilized
Oh,
plants
yeah.
for MF. Median height. Self-fertilized plants. So since we are planning to do a two-tailed, you can tell me what the null and the alternative are. Yeah.
The null would be the median of C is less than or equal to.
Two-tailed.
Two-tailed, but never mind equal.
Never mind equal. What is that?
Never mind, I'm just not gonna.
Never
answer it.
mind.
Well, yeah, pi less than or equal to is never mind. Whatever. You knew that I meant.
I know. But still.
Oh, I get it now.
Just like
Okay.
I mean, I'm just returning the love back that you showed me earlier.
Yeah.
How did he end this?
Sharing is caring.
Thank you.
So no, the median height of cross-fertilized plants is equal to the median height of self-fertilized plants. Alternative, they're not equal. We know how to test for normality. One, we can do a picture, right? Two, we went over this. There is a test. Say that. Shapiro test, Shapiro-Wilk. So I'm going to do Shapiro-Wilk on each of those samples to see if they are null.
TJ, I understand things now.
Very good. It takes time, but
I get it. What would you have done? Which tail would you have done if I didn't say?
Tail.
I would have gone for not equal to. It is the most powerful test because if you can do it for not equal to, which is two-tailed, you can make inferences for right or left using that. It is the most powerful test.
There is a reason why I'm doing this test. Learn from mistakes.
Let's say if you remember, if the null is rejected in a Shapiro-Wilk test, what does it say about the sample? Is the sample normally distributed or is it not normally distributed? If we reject the null in Shapiro-Wilk, are we saying that the sample is not normally distributed? Yes or no? Reading helps. Should be in your notes. If we reject the null in Shapiro-Wilk,
Rejecting null check.
what does it mean?
It means
Does it mean
it's not
that the
normal.
Very good. The sample is not normal. Now, of the two, one of them is not normal. Which one? Cindy,
The cross,
the cross. Why? Enlighten us.
Because the p-value is lower
oh, if he's low, rejects H, oh.
Exactly. P-value is extremely small, less than 0.05. We'll be rejecting the null. So the cross sample is not normally distributed.
Because it's less than 0.05.
Mm-hmm. It's 0.000. I believe there was another zero. Maybe not. Nope. 97. Approximately. Clearly less than
Yeah.
0.05.
That's 0.97.
The sample for self-fertilized plants is normal. This is actually a nice example for all the hate that Phoebe showed toward Darwin.
It's just,
So why is this a great example? One of the samples is not normal, the other is normal. Can I use a t-test?
On the one that's normal, we got that though.
We are doing a sample t-test independent case. Absolutely not. Both populations need to be normal in the sense the sample should also be normal. Clearly, no. In this case, the appropriate test will be Wilcoxon.
and we're doing that anyway.
Yep.
You're right, this was a good example, whatever.
So Wilcox test. The first sample is cross, second self. Paired equals false. Later we will do paired equals true. By later I mean next class. That is the case where we would be doing dependent samples. Alternative, two-sided. Good. The rest I'm just going to leave it as default. Okay. Something very important. What does it say here?
Can't, with ties.
Ties. I mentioned that as far as this class is concerned, I'm not going to put an example that has ties because it will make the calculations extremely complicated. And we want to keep this class as applied as possible. It's called applied stats, just in case. So anytime you have ties or cannot compute p-values, again, there is theory behind it. So do we see the test statistic U? Yes, then. 185.5. The p-value is 0.002608. Based on the p-value that you see, do you believe that the median height of cross-fertilized lines are the same as the self-fertilized lines? Do we have evidence to support that?
Yeah, we do.
That they are the same?
That they're not.
Very good. So since we are rejecting the null, we don't have evidence to support the null, we have evidence to support the alternative. So p-value which is less than 0.05, that would imply we reject HO. Anyone can do this, but you should know how to explain this to people. Interpreting, understanding is important. How would I explain this? Well, let's do it in the next slide. To conclude, median height of plants that are cross-fertilized is not equal to those that were self-fertilized. Are we clear? Yes? No, this actually became a very good candidate for a couple of reasons. One, sample size, small. Two, violation of normalcy. A two-sample t-test definitely is not applicable. Any questions?
What should we read again?
Oh, Jonathan, finally, you're interested. What should we read? I am going to send an announcement today. And in that announcement, I will summarize the topics that we need to go over, the notes, as well as the examples. And I'll post the scripts in Canvas. Run it, understand it, everything in conclusion. Understand. If you have questions, what do you do? That or ask. Good. Okay. Thursday we will start Wilcoxon Rank, and then we should be done. Thank you for sitting through the entire thing. I appreciate it. Yeah, I'll talk to you later. I mean, as long as I have a, good force of check. Okay. Well, APTR is due on 31st, so
Oh, art tab?
Yeah, more or less.
That's what I'm
I'll put it-
I feel like everyone is gonna go to the.
It's 8 whole cereals.
Just, I hope I find it. Just look. I won't be there though. Okay.
Bye, BJ.
Yeah, no, I guess I see super around, there's, it's not worth it. Good day.
Oh, it's so cool.
That's like prop up. I think we're gonna have to cut it down. It's so good. You also have the- Yeah, I haven't watched that movie either.
I think it's so gross.
Yeah, I texted my brother, so I was like, hey, like, maybe we should talk about it. I haven't even like. I watched it on Sunday.
I'm just saying.
It's not really hard, I haven't looked at it. No, just follow the movie. It's the paper stuff too,
No,
right?
okay, so she showed me, and apparently it's in the first scene where she's found.
Oh, yeah. Yeah.
Yes.
That's like April for the morning outage. Oh.
She said like.
It is freezing. It's also. Yeah, it's like, I know you're so. Yeah, I, that's it. It's warmer.
Yeah, but
Right.
Sandy, I love your
shirt.
shirt. And I used to, I literally just started.
And the peanuts. And they really Should I turn it in?
It's a lot. It's like I was listening to a course where I'm like, no, it's just. No. For someone who like struggles with like.
Yeah, I regretted the question too. I just
I'm
like
gonna do like a lot later.
Do you wanna see them? Yeah, I just.
Yeah, I do.
Oh,
No,
okay.
I'm gonna change. I'm not presenting. Yeah, I am. And like before I get into it,
Right.
I just.
Presentation.
I know we want it. Because it's like, it's so
Okay,
it's
so-
like child abuse.
Yeah. Like, I won't
I
be
want to like
for
start myself.
But mine.
It's legal.
Oh, yeah, mine is still illegal.
But
But
like, why am I going in? I don't know.
I mean, this is that even worse.
Yeah, no, I know when I saw it, like the people we love itself, but at the same breath, it's like, not if it's like only just 2 days. I don't have to. I don't know. Slowly, but steady, yeah, just slow and steady.
Yeah.
Without having to like be like.
Yeah, I'm like, so big up now, you know, that so big fan, I would be like.
So, and like, but like, I mean. But it's like a sad position that I like still understanding. And then now, it's
Going to a